Yeah, Hi everyone, my name is Junhao, and in this video, I will introduce our final project, a real-time traffic aware routing system for Manhattan. As the goal of this project is to compute the fastest route, not just shortest one, by dynamically incorporating the live traffic data into a road network graph. And here is our GitHub homepage, and you can see there's many instructions here. The first step is how to run the basic navigation, and we will talk about later on our demo time. And here's our overall file structures, and this diagram shows the overall system pipelines. And you can see the first part is the map and dataset part. For the road network, I use OSMNX to download the full Manhattan map, and the processed graph contains tens of thousands of nodes and edges, and I serialize it using a JPEG files for fast reuse. And for the traffic data, I fetch the live speed information for every road segment roughly every 2 minutes, and using the here traffic flow API, and each snapshot contains around 38,000 traffic segments, and which I will show you later. And the next stuff is the matching stuff. And one of the main technology challenges is that here and here API and OSMNX represents the road differently. Here traffic data represents the road as line strings with speed values, while OSMNX represents the road as graph edges with different segmentations. To resolve this mismatch, we use the special nearest neighborhood matchings. We build up the str tree special index over all OSM and X edges geometries, and for each here traffic segment, I query the nearby OSMX edges and select the closest one based on the geometric distance, and this allows us to efficiently update the per edge speed across the entire Manhattan graph. And the next part is our machine learning part. You can see we use the random forest predictions. For each edges we can check there's any edges exist, and if there are matches, we will use the random forest predictions and update these new edges if you do a long time trip. For example, set 30 minutes. If you do that you do the trip longer than the 30 minutes, you implement the measuring part for since after maybe like after 30 minutes the road situation will change, and we will make sure to get the fastest pass by this way. And if you want to do the machining part by yourself, you can also do that. It's already uploaded, and you can use the notebook and yeah, do it by yourself. And the next part is the demo part. By the way, I want to also mention, like, if you want to implement this stuff on the other area, you can also use the build graph to download the other areas map, and yeah, you can change the here API stuff to get the live data, and you can implement this on other area too. And since yeah, now it's our backend part. Let's do for a demo time. First do the backend part. For the instruction, you can see blah 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 blah. I run it backend. You can already run it first. Okay, this one is already running, and I will interrupt it. And yeah, and also I want to mention one stuff. The files we uploaded for the GitHub, the here key is empty in the app.python, and you need to get your own one in the here platform, trackflow platform. And since it's free for the basic implementation, so there's no big worries about this. You can get your own one easily, and I already got my own one on this one. Yeah, So after you see that there is first 37,000 segments, it means the live data already updated, and you can see the graph city and travel time is already updated, and it's already loaded the data, the Manhattan graph, and that means it works. And then you can open your browser, and with this link you can see here. Here is our backend, routing backend is running, and here we also you can use this command to get your data. And here's some examples. This is the start coordinates, and this is a destination coordinates. And after that, paste that, you can just paste on and do that. Yeah, you can see. Here we go. You can see how the data is, so how the API works. It returns some coordinates. That means the node, each node, and this is the routing model and the total distance and the estimate time. Yeah. And after the backend running, now the next step is running the front end, right? The front end is already okay. So copy this stuff. Copy this stuff. You can share it and run it. That means it started running. Yeah. And then open this link. And now we got it. Some simple map, and you can zoom it up, zoom it down, and then follow the instruction. We can click on the maps. The first click is start, the second click is the end, and the distance is already shown here, and the estimate time is it's also shown here. Yeah, here we go. And you can see if we click outside the Manhattan, it's not working, since we only upload the Manhattan's map, so it will only work on the Manhattan area. Yeah, so that's it. And oh, I want to also mention one stuff. Since the traffic light live data is not available, and so we cannot do some stuff working on the traffic light, so that is a hard problem. So after that, we decide to add some penalty on each node based on their row type, which is parameters in the dataset, and you can see it in the dataset if you want to see. Yeah, and yeah, I think that's all instruction videos. And thank you for watching, and thank you for your time. Yeah, if you want to get more information, you can get it. You can get it from our GitHub page, and we will also upload our report files on it. You can get it's more detailed, and yeah, and I will post the link below the video. Thank you guys.